I have a dream that one day
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
In this introduction to arithmetic progressions, or APs, we want to look at the following important concepts. Firstly, the definition of an AP. Then secondly, the fundamental property of APs. Thirdly, the value of the nth term. Number 4, linearity of APs. And then lastly, the sum formula. An arithmetic progression, or AP, also known as an arithmetic sequence, is a sequence of numbers such that the difference between consecutive terms is constant. Let's take an example. Let's say we have the sequence of numbers 1, 4, 7, etc. We add 3 each time to get to the next term in the sequence, so the common difference is 3. Let's take a second example. Let's say we have the sequence of numbers 5, 1, -3, etc. In this case, we are subtracting 4 each time, or seeing it in another way, we are adding -4, so the common difference is -4. Let's look at what is meant by the fundamental property of APs. If tk minus 1, tk, and tk plus 1 are 3 consecutive terms of an AP, then tk plus 1 minus tk is the same as tk minus tk minus 1. Let's take an example. Let's once again look at the sequence 1, 4, 7, etc. And let's say these are the first 3 terms of an AP. Then t1 is the first term, and that's equal to 1. t2 is the second term, which is equal to 4. And t3 is the third term, which is equal to 7. Then t3 minus t2 is equal to 7 minus 4, and this is equal to 3. And t2 minus t1 is equal to 4 minus 1, which is also 3. So from this we can see that t3 minus t2 is the same as t2 minus t1. We now want to come up with a formula for the value of the nth term of an AP. Let's consider a sequence or arithmetic progression where the first term is A and the common difference is D. So to get to the second term, we add D to the first term to get A plus D. Then to get to the third term, we add D to the second term, so we end up with A plus 2D. So T1, the first term, is equal to A. T2, the second term, is equal to A plus D, and T3, the third term, equals A plus 2D. Let's look at these 3 terms in more detail. Term 1, or T1, is equal to A, which is the same as A plus 0D, and this is equal to A plus 1 minus 1D. T2 is equal to A plus D, which is the same as A plus 2 minus 1D. And T3 is equal to A plus 2D, which is the same as A plus 3 minus 1D. Continuing with this pattern, we see that Tn, the nth term, is equal to A plus n minus 1D. So in the formula T sub n equals A plus n minus 1D, A is the first term, D is the common difference, n is the number of terms, and T sub n is the value of the nth term. Let's look at the linearity of APs, and let's once again look at the sequence 1, 4, 7, etc. So T1, the first term is 1, T2, the second term is 4, and T3, the third term is 7. We can write down the results in a table. So we see that when n is 1, T sub n is 1. When n is 2, T sub n is 4. When n is 3, T sub n is 7. And we can plot this on a graph where the x-axis has n and the y-axis has T sub n. We see that we get a straight line relationship or a linear relationship. Note that we don't connect the points since n is an element of natural numbers. So there are no T sub n values for numbers between the natural numbers. For example, between 1 and 2 or between 2 and 3. Now, let's look at the formula T sub n equals a plus n minus 1 d more closely. We can manipulate this equation slightly. We can multiply the brackets and regroup the terms. And we see that we get T sub n equals dn plus a minus d. And this is in the form y equals mx plus c, where T sub n is y, d is m, n is x, and a minus d is c. So we have a linear relationship for this equation, and hence APs are also known as linear progressions. Let's look at the sum formula for an AP. Let's say we have an AP with n terms, a plus d, a plus 2d, all the way up to a plus n minus 1d. And let's say we want to add all these terms. We write S sub n, so S sub n equals a plus d plus a plus 2d plus all the way up to a plus n minus 1d. When we add the terms of an AP or a sequence, we call it a series. And we can get the sum by using the formula S sub n equals n over 2 into 2a plus n minus 1d, where S sub n is a sum to n terms. Carl Friedrich Gauss was a German mathematician and physicist who lived from 1777 to 1855. Because of his numerous contributions to mathematics, he is by many people regarded as the best mathematician who ever lived, and is often referred to as the Prince of Mathematicians. Gauss was a child prodigy, and when he was 10 years old, his class teacher asked him the following question: what is the sum of the first 100 positive integers? In other words, what is 1 plus 2 plus 3 plus all the way up to 100? Within minutes, Gauss gave the answer, and we want to know how he did it so quickly, because this forms a basis for the proof of the sum formula. So we want to know what is the sum of the first 100 positive integers. We start by writing out the series, so S sub n, where n is 100, equals 1 plus 2 plus 3 plus all the way up to 100. Now we rewrite the series back to front. So we start with the last term, which is 100. Now the common difference here, of course, is 1. When we write the series back to front, we subtract 1 each time to get to the next term. So 100 minus 1 is 99. 99 minus 1 is 98. And so we can continue subtracting 1 and adding the terms until we get to the first term, which of course is 1. Now we add the two series. So S sub n plus S sub n is twice S sub n. 1 plus 100 is 101. So we add corresponding terms. 2 plus 99 is 101. 3 plus 98 is 101. And we continue adding terms until we get to 100 plus 1, which is also 101. So we basically have 100 101s. Now, when we add something to itself n times, it's the same as multiplying that thing by n. So here we are adding 101 to itself 100 times. So it's the same as 100 times 101. Now, note that the 101 is basically the first term, which is 1, plus the last term, which is 100. We now divide by 2. So we get S sub n, 100 divided by 2 is 50. S sub n is 50 times 1 plus 100. And we can do this multiplication very easily. 50 times 1 is 50. And 50 times 100 is 5,000. So our answer then comes to 5,050. Let's look at the proof of the sum formula. We start by writing out the equation for S sub n. In other words, a plus d plus a plus 2d plus all the way up to a plus n minus 1d. We call this equation 1. And we let the last term or the nth term, in other words t sub n, equal L. Now we rewrite the equation back to front, starting with the last term L, and in this case subtracting d each time until we get to the first term a. We call this equation 2. We add equations 1 and 2, and on the left hand side we get twice S sub n. Notice that the d's cancel when we add corresponding terms on the right hand side. So we end up with a plus L added to itself n times. When we add something to itself n times, it's the same as multiplying it by n. So on the right hand side we get n times a plus L. We now divide by 2 on the right hand side, and then we replace L with the original term a plus n minus 1d, and adding the a's in the square brackets gives the desired result. "95% of problems that you'll encounter for APs are based on the following 7 techniques. Firstly, using the formula T sub n equals a plus n minus 1d. Then secondly, using the fundamental property. Thirdly, using the sum formula. Then we have simultaneous equations, sigma notation, word sums, and application problems. In the next few lessons, we will look at these in great detail. The first of the 8 standard techniques for APs deals with using the formula T sub n equals a plus n minus 1d. There are 4 sub-techniques. These are finding the value of the nth term, finding the number of terms, using the general term, and divisibility problems. So in this example it says, find the value of the term as indicated for each of the following sequences. And in the first one, we have the sequence 1, 5, 9, etc. And we must find the value of the 10th term. So let's do that. We can start by checking that this is an AP. So we have term 1, term 2, and term 3. Then term 3 less term 2 is going to be 9 minus 5, which is 4. And term 2 less term 1 is 5 minus 1, which is also 4. So we know it's an AP with common difference D equal to 4. Now we can use the equation T sub n equals A plus n minus 1 times D. And we plug in the values. We want the value of the 10th term, so we want T sub 10. A is the first term, and that's equal to 1. N is the number of terms, and we want the value of the 10th term. So n is 10, so we have 10 minus 1, which is 9. And then times the common difference of 4. And this comes to 37. So the value of the 10th term then is 37. Let's look at B, or rather 2. Once again, we can start by checking that this is an AP. So term 3 less term 2 is negative 3 minus negative 5. And this is negative 3 plus 5. A minus times a minus being a plus. And this comes to 2. Then term 2 minus term 1 is negative 5 minus negative 7, which is negative 5 plus 7, which is also 2. So we know it's an AP with common difference D equal to 2. Once again, using the formula T sub n, we want the value of the 15th term. So it's T sub 15 equals A, which is negative 7, plus 15 minus 1 is 14 times D, which is 2. And this comes to 21. Let's look at your answers to this question. In the first one here, we have the sequence 7, 4, 1, etc. And we must find the value of the 18th term. So let's first check that this is an AP. So term 3 less term 2 is 1 minus 4, and that's equal to negative 3. Then term 2 less term 1 is 4 minus 7, which is also negative 3. So we know it's an AP with common difference D equal to negative 3. Now we use the formula T sub n is A plus n minus 1 times D, and we plug in the values. We want the value of the 18th term, so we want T sub 18. And A is the first term, and that's 7. N is 18, so we have 18 minus 1, which is 17, times the common difference of D, which is negative 3. We can use a calculator. So let's see, 7 plus 17 times negative 3. And we get an answer of negative 44. So the value of the 18th term is negative 44. Let's look at the second sequence here. We have negative a half, a quarter, 1, etc. And we must find the value of the 30th term. So let's once again check that it's an AP. So term 3 less term 2 is 1 minus a quarter. And we can do this on a calculator, but 1 minus a quarter is 3/4. Then term 2 less term 1 is a quarter minus negative a half, which is a quarter plus a half, which is also 3/4. So once again, it's an AP. And in this case, the common difference D is 3/4. We now use the formula T sub n again, and we want the 30th term, so we want T sub 30, which is A. In this case, A is -1/2, plus n minus 1, which is 30 minus 1, in other words 29, times D, which is 3/4. So let's see what that comes to. So it's a half, or rather -1/2, plus 29 times 3/4. And that comes to 21,25, or 21 1/4. In the first question here, we are given the series and we must find the number of terms in it. Remember that a series is just a sequence where we add the terms. So let's look at the answer. First, we're going to check whether this is an AP, since we are not explicitly told so. So let's take term 3 less term 2, and it's 293 minus 297, and this is -4. Then term 2 less term 1 is 297 less 301, and this is also -4. So we know it's an AP with common difference D equal to -4. Now we're going to use the formula T sub n equals A plus n minus 1 times D. Let's write down what we have and what we need to find. We have the first term, A, it's 301. We've got the common difference D, which is -4. We have the value of the nth term, T sub n, which is basically the last term, -15. And we must find the number of terms n. So let's plug into this equation. T sub n is -15. A is 301. N is what we need to find. And the common difference D is -4. We have to solve for n in this equation. We can first take 301 to the left-hand side. We don't multiply into the brackets here. We now divide by -4 on both sides. So we have -316 divided by -4 equals n minus 1. We can use a calculator. 316 divided by 4, and it comes to 79. So n minus 1 is 79, and solving for n, we see that n is 80. Let's look at the second question here. It says, determine which term in a series, 7 plus 10 plus 13, etc., will be the first term to be greater than 150. Let's first check whether this is an arithmetic series. So term 3 less term 2 will equal 13 less 10, which is 3. And term 2 less term 1 will be 10 less 7, which is also 3. So we know it's an arithmetic series. So it's an AP with common difference D equal to 3. Once again, we're going to use this formula T sub n equals A plus n minus 1 times D. Let's write down what we have and what we need to find. We have the first term A, it's equal to 7. The common difference D is equal to 3. T sub n must be greater than 150. and we must find the value of n. Let's plug into this equation. So a is 7 plus n minus 1 times d, which is 3. This is the value of the nth term, and this must be greater than 150. So we have 3 into n minus 1. We can take the 7 to the right-hand side. And now we can divide through by 3. So n minus 1 is greater than 143 divided by 3. Let's check on the calculator. 143 divided by 3 is 47,67. So this is 47,67. And we solve for n by taking negative 1 to the right-hand side. So n will be greater than 48,67. Now we know that n is the number of terms and it must be a natural number. So the first number, or the first natural number greater than 48,67 is 49. So n is equal to 49. So this means that the 49th term in this series will be the first term to be greater than 150. Let's look at your answer to the first question here. We're given the sequence and we have to find the number of terms. Let's first check whether this is an AP. So term 2 less term 1 is 10 less 7, which is 3. And term 3 less term 2 is 13 less 10, which is also 3. So we know it's an AP with common difference d equal to 3. We're going to use the formula again, t sub n equals a plus n minus 1 times d. Let's write down what we have and what we need to find. We've got the first term a. The value of a, of course, is 7. So 7. The common difference d is 3. We also have the value of the nth term, or the last term. It's 280. So t sub n is 280. And we want to find the value of n. In other words, a number of terms. So just plugging into this equation, 280 equals 7 plus n minus 1 times d. We can take the 7 to the left-hand side. So 273 equals 3 into n minus 1. Now we just divide by 3. So n minus 1 is 273 over 3. And that's going to be 91. And from this, we can solve for n. N will be equal to 91 plus 1. Or 92. Let's look at your answer to the second question here. We are told that this is an arithmetic series and we must find the first term to be greater than 10 or to exceed 10. Since we are told this is an arithmetic series, we don't have to check. We can find the common difference d by taking term 2 less term 1. So it's negative 58 minus negative 61. So it's negative 58 plus 61, which is 3. Now we're going to use the formula t sub n again. So t sub n is a plus n minus 1 times d. Let's write down what we have and what we need to find. The first term a, of course, is negative 61. The common difference d equals 3. We have to find the first term to exceed 10, so we know that t sub n must be greater than 10, and we need to find n. Let's plug into this equation. So a, which is negative 61, plus n minus 1 times d. This is the value of t sub n, and we know that t sub n must be greater than 10, so this must be greater than 10. Let's take the negative 61 to the right-hand side, and on the right-hand side we get 10 plus 61, which is 71. We divide by 3, so n minus 1 is greater than 71 divided by 3. On a calculator, this comes to 23,67. And finally, we can solve for n. We take the negative 1 to the right-hand side, so n is greater than 24,67. The smallest natural number greater than 24,67 is 25. So n will equal 25. In this example, we are given this arithmetic sequence, and in the first question, we have to write down the general term of the sequence. Now, in order to answer this question, we will always use the formula t sub n equals a plus n minus 1 times d. And then we merely replace a and d with the numerical values in order to find the general term. So a, the first term, is 2. We keep n. And then d, of course, is 3. We are adding 3 each time to get to the next term. So it's times 3. And then simplifying, we get 2 plus 3n minus 3. And we find the general term comes to 3n minus 1. So that's t sub n, the general term. Often we also use k in the place of n. So we could have written it as t sub k equals 3k minus 1. In 2.1, we have to use the answer in number 1 to find the value of the 13th term. And this is quite easy now that we have the general term. All we do is to replace n with 13. So it's 3 times 13 less 1, and this is equal to 38. In 2.2, we have to use the answer from number 1 to find out which term equals 92. Once again, we just make t sub n equal to 92 in the equation for the general term. So 3n minus 1 must equal 92. We solve for n, and we find that n is 93 divided by 3, which is 31. In other words, the 31st term will equal 92. Let's look at your answers to this question. We have this arithmetic sequence, and in number 1 we have to write down the general term of the sequence. We start by writing down the values of a and d. A is the first term, and that's 7. D is the common difference. We can get d by taking term 2 less term 1, so 1 minus 7, which is negative 6. Now we use the formula t sub n. equals a plus n minus 1 times d. And we replace a and d with the numerical values 7 and negative 6. So 7 plus n minus 1 times negative 6. We simplify, so it's 7 minus 6n plus 6, which is 13 minus 6n. So the general term then is 13 minus 6n. In 2.1, we have to use the answer to question 1 in order to find the 33rd term of the sequence. And we merely replace n with 33 in the equation for the general term. So it's 13 minus 6 times 33. And let's see what that comes to. So 13 less 6 times 33. And it comes to negative 185. So negative 185. Let's go to 2.2. We have to find out which term will equal negative 101. So we merely make t sub n equal to negative 101 and we solve for n. So 13 minus 6n must be negative 101. We solve for n. And n will equal negative 114 divided by negative 6. So let's see what that comes to. It's 114 divided by 6. And that comes to 19. So n is equal to 19. Let's look at example 1D, which is an example on divisibility. It says consider the sequence, and we are given the sequence of numbers. And in A, we have to write down the value of the nth term of the sequence in the form t sub n equals an plus b. Now, firstly, let's check to see whether this is an AP. So, term 3 less term 2 is negative 3 minus 1, which is negative 4. Then term 2 less term 1 is 1 minus 5, which is also negative 4. So we know it's an AP with common difference negative 4. Now, to go back to A, we have to write down the value of the nth term. This is another way of asking us to find the general term. And we know that to find the general term, we need the value of A and we need the value of D. We already have the value of D, so we can write down the value of A, the first term, and that of course is 5. Now we're going to use the formula T sub n equals A plus n minus 1 times D. And we merely plug in the values of A and D. So A is 5, we keep n, and D is negative 4. So we simplify this, we get 5 minus 4n plus 4, and this of course is minus 4n plus 9. So we have the form T sub n equals an plus b. We can see that A is equal to negative 4 and B is equal to 9. The second part of this example deals with divisibility. It says determine the number of terms in this sequence that will be exactly divisible by 5. The key to answering this question is to write out as many terms as necessary to see which terms are divisible by 5 and to see whether we have a pattern. We want to have at least 3 terms in the sequence, or the first 3 terms in the sequence divisible by 5. So let's write it out. So we have the first term 5, which is divisible by 5. The second term 1 is not divisible by 5. Neither is negative 3. We know that the common difference is negative 4. So we keep on subtracting 4. So we get negative 7, negative 11, negative 15. And negative 15 is divisible by 5. So we have at least 2 terms now divisible by 5. Let's continue. So we get negative 19, negative 23, negative 27, negative 31, negative 35, and we have another term divisible by 5, which is negative 35. So we can stop here because we have at least 3 terms now divisible by 5, or the first 3 terms. So we see that we have another arithmetic progression within the original one of terms divisible by 5. So we have a new AP made up entirely of terms divisible by 5. So it's 5, negative 15, negative 35, etc. It's a new AP because it's a common difference, in other words D, of minus 15 minus 5, term 2 minus term 1. And so this is negative 20, the common difference. Now we want the number of terms divisible by 5 within the original sequence. In order to find the number of terms, we will need the last term. We also know that A, the first term in this new AP, is 5. We need to find out what T sub n equals. Now, if we go to the last term in the sequence, we see that it's not divisible by 5. We can check on a calculator. So it's 4187 negative. If we divide it by 5, we don't get an integer. So it's not divisible by 5. So we want to find out which is the last term in the original sequence divisible by 5. So we start with the last term. We know the common difference is negative 4. To get to the second last term, we add 4 to the last term. So minus 4187 plus 4 will be minus 4183. And we can check on the calculator to see that this is not divisible by 5. Let's find the next term. So minus 4183 plus 4 is minus 4179. This is also not divisible by 5. Checking on a calculator. Let's check the next one. So we're working backwards from the last term. So this is minus 4175, which is divisible by 5 if you check on a calculator. So 4175 negative divided by 5. We do get an integer. So the last term in the original sequence divisible by 5 is negative 4175. So we can put it into the sequence here. Remember that we're trying to solve for T sub n, or rather we need a T sub n in order to find n. So we just plug into the equation t sub n equals a plus n minus 1 times d. So t sub n is minus 4,175. A is the first term, that's 5, plus n minus 1 times d. And we saw that d was negative 20 for this new AP. And just solving for n, we can bring the 5 to the left-hand side. Dividing by 20, or negative 20. So 4180 divided by 20 is 209. And in solving for n, we find that n is 210. So that means that there are 210 terms in the original sequence that are divisible by 5. Let's look at your answers to this question. We are given this arithmetic series, 2 plus 9 plus 16, etc. We are told that there are 251 terms in the series. And in A, we have to write down the fourth term of the sequence. We can see that the common difference D is 7, since we have to add 7 each time to get to the next term. So to find the fourth term, we merely add 7 to the third term to get 23. Then we have to calculate the 251st term of the sequence. And we use the formula T sub n equals A plus n minus 1 times D. And we want T sub 2 51. So the first term A is 2. Then n is 251. So we have 251 minus 1, which is 250, times the common difference D, which is 7. We can do this on a calculator. So it's 2 plus 250 times 7. And it's 1752. In C, we have to calculate how many terms are divisible by 4. So once again, we're going to write out the sequence. So it's 2, 9, 16. So 16 is the first term divisible by 4. We keep on adding. So 16 plus 7 is 23. Then we are 23 plus 7, of course, is 30. 37, 44. 44 is the second term in the sequence divisible by 4. Then adding 7, we get 51, 58, 65, 72. 72 is another term, or the third term in the sequence divisible by 4. So we have at least 3 terms. So then all the way up to the 251st term, which is 1752. Now we can check to see whether this is also divisible by 4. So 1752 divided by 4. We get an integral answer, so it is divisible by 4. So we now have a new AP of terms divisible by 4. The first term being 16, the second term being 44, the third term being 72, and the last term will be 1752. We can check that this is an AP by taking term 2 minus term 1, term 2 minus term 1, and then term 3 minus term 2. In this case, we see that the common difference D is 28. So we must find the number of terms in this new AP. So once again, using T sub n equals A plus n minus 1 times D. The nth term is 1752. The first term is 16. We want n, and the common difference is 28. We can solve for n. (1752) minus 16 is 1736. And now solving for n, so n minus 1 will be 1736 divided by 28. Let's see what that comes to. And it's 62. And then n will equal 62 plus 1, which is 63. So there are 63 terms in this original sequence divisible by 4.